Greetings to you all. Welcome to my explainer video. In this video, I'll be explaining a concept from aerodynamics application called Vortex Generators, and I'm going to go deep into explaining how these small devices affect the boundary layer of wings of an aircraft. Have you ever looked outside an aircraft and seen these fin-like structures on the surface of an aircraft? These are what we are going to be discussing throughout this video. By definition, a vortex is more like the spinning of a fluid being either water or air, but in our discussion, air is the working fluid, the spinning along a center line, a common center point, in such a way that the fluid that's spinning is drawing things to the center. These examples of vortex is a whirlwind, a tornado, the galaxy itself, and you can also see it when you spin a bottle of water. The bottle of water produces that spin, and for that spin, that is also what a vortex is. So vortex generators essentially produce some sort of spinning on the surface of the wing, and now we're going to discuss how this spin is important to the overall performance of an aircraft, and also in applications of vehicles. They are there. In order to understand the study of vortex generators, it's essential for us to understand some of these keywords: the vortex, boundary layer, laminar and turbulent flow, attachment, separation, adverse pressure gradient, as well as stalling. We've already explained what a vortex is, and we'll take a deep dive into the science behind. A boundary layer, by definition, is a thin microscopic layer of a fluid in the immediate vicinity of the solid surface where fluid's velocity and temperature are significantly altered by friction and heat transfer. This is the layer. This is the surface, and you have a fluid flowing above the surface. There's a layer that is formed on which the velocity of the fluid is gradually increasing until it reaches the free stream velocity, which is the entire velocity of the fluid. Now, this layer on which it's increasing, it's zero at the contact of the surface. This layer on which it's increasing is what is called the boundary layer, and it's usually 99% of the free stream. The velocity at which is 99% of the free stream. This thickness, distance from here to here, is what they call the boundary layer. And it's a very important concept to the working principles of these vortex generators. As air is flowing, uh, air can either be attached to the body or separate. So there are two types of flow: attached flow and separated flow. Attached flow is flow in which the air is continuously in contact with the body or the solid surface, while separated flow is the boundary layer detaches from the surface of the body. This detachment is caused by a what we call adverse pressure gradient. Adverse pressure gradient is as the air is flowing above, because this is a viscous fluid, friction is experienced at the surface of the body, and as the air is flowing, the velocity of the flow reduces gradually to the end. And when velocity reduces through Bernoulli's principle, the the as velocity reduces, the pressure increases. So the pressure at the back is higher than the pressure at the front, and because of that, the pressure is pushing the air backwards, and this air gets detached. The detachment happens because the energy depends on the energy that the air is carrying. The faster the air is moving, the more the energy that it has, and therefore the detachment will happen later because the air has got more energy. Why is it important for us to understand this whole detachment, attachment, and the detachment of the boundary layer? It's important because in order to create lift, it is essential that the air moving on the top surface of the wing, the one moving at a higher speed compared to at the bottom, must complete its full travel in order for the pressure at the top to reduce compared to that at the bottom. At the top is moving a longer distance compared to at the bottom, or meeting at central point at the back here. Because they're meeting at the same time, the air moves a longer distance because of the camber, and therefore moving faster and producing low pressure, and this is what produces a lift that lifts the aircraft. Now, if the air separates, it's going to affect the lift of the aircraft, and we're going to experience a condition that is called stalling. The aircraft loses its lift. It's difficult to control the aircraft, as well as is a drag that's formed due to this separation bubble here. This drag is this work is produced separation bubble, and there's a drag that's produced called pressure drag. So this, we do not want the air to separate. It is essential for the air to continue, the boundary layer to be stuck to the surface at all times. Before we go into the discussion of the vortex generators, first I have to explain on laminar and turbulent flows. Laminar flow is when the streamlines are parallel to one another, while turbulent flow, they are randomly dispersed even as they go in the direction of flow. Now, you observe that in the first bore that is experiencing laminar flow, the detachment happens earlier compared to in a turbulent flow. That is because in turbulent flow, despite it being random, there is more energy in this randomness, and therefore it is more difficult for the airflow to detach from the surface of the from the surface, as unlike in laminar flow. So essentially, creating more turbulence on the surface of the surface is what's going to allow for more attachment of the boundary layer. These vortex generators form vortices, as we've explained. They are like more like tornadoes on the surface. These vortices are produced because these vortex generators are inclined at a certain angle from the direction of the flow. So sometimes 15 degrees. As the flow comes, it hits the surface of the vortex generators, overlaps and produces these vortices. These vortices tap in from the free stream air at the back, at the top, sorry. At the top, this free stream air is has got more energy, this red zone, compared to the one at the bottom in the boundary layer. So the air is tapped from the top, produces this tornado entering the boundary layer and essentially re-energizing the boundary layer. Therefore, because more energy has been put into the boundary layer may not separate easily. And that is depicted between these two images. This is a vehicle, the back window of the vehicle without vortex generators, and that one with vortex generators. As you can see, with vortex generators, the airflow manages to pass through on top. While this one, there's this wake, the wake that's produced. You can't see it, but the effects can be seen. So, in summary, the vortex generators disrupt the airflow, form the vortex, pull energy from the free stream, and then this pulled energy from free stream is what's responsible for the attachment of the boundary layer in further ahead. Applications of this concept are in general aviation, transonic aviation, and motorsport. In general aviation, you want to be able to fly the aircraft at low speeds. That's at landing. When you want to land, you want to fly the aircraft at low speeds. It's essential to fly at low speeds, and vortex generators allow us to do that because the at low speeds, the friction of air is higher. The friction is already high. Now at low speeds, because the speed is lower, the detachment will happen is faster than it would happen if the aircraft is moving faster. So now these vortex generators allow us to move slower and also retaining the effect of us still having lift and it not stalling. Apart from low speed, it also allows us to have higher angles of attack. Angles of attack are how the aircraft pitches up. The higher it can pitch, the easier it is for it to climb. Now, if it pitches more, as it pitches more, the chances of that weight being produced are high, and therefore the aircraft can stall. Now, with vortex generators, the airflow will still stay attached to the surface despite that pitch. Intrasonic aviation is what they call shock waves, a layer at which the fluid properties change drastically. This change drastically produces a lot of drag, it produces effects, the boundary layer may separate and all that. So when you have vortex generators, it re-energizes the boundary layer. Despite the presence of this shock wave, the boundary layer can still stick to the surface of the aircraft, and therefore increasing the capabilities of control in high speed aircrafts. that may be in the military or some in general aviation for those who use high-speed aircrafts in general aviation. Also in vehicles, the spoiler at the back is more like a wing, so it needs some air from the back. Without these vortex generators, the air can produce a separation bubble here, but the vortex generators allows the air to stick to the floor, allowing it to pass through the spoiler and producing that downforce. Spoiler is like an inverted wing, producing that downforce that makes the car stick to the ground. So we've talked about the boundary layer and why it's important for us to have this to understand the boundary layer and how the principles of the layer go uh, about with the production of lift and the like stalling. We've explained on vortex generators, what a vortex is, how the vortex generators will energize the boundary layer, and also the applications of the real world applications of this principle. Commonly asked questions: how do you determine where to place the vortex generator? Determining where to place the vortex generators is highly dependent on the mission. If it is for better control on the control surfaces, you have to place them there. If it's for stalling, you want to delay stalling, you place it on the wings for vehicles and all that. So it depends on the mission, and depending on the mission, also we make use of computer aided engineering softwares like ANSYS. We design the whole thing in the computer and see how they perform at different levels, and percentage wise we're going to determine at the point at which it's best placed. We also use wind tunnel tests. We place them, we create a prototype, place the vortex generators and see exactly where they produce the best effect in the wind tunnel. What are some of the design considerations? Design considerations may be the thickness of the boundary layer, because if the boundary layer is too thin, therefore you can also use small vortex generators. If it's too thick, you can't use. If you use small vortex generators, the energization may not be as much as compared to the latter. So you put in all those design considerations. Do all aircrafts or vehicles need vortex generators? The answer is no. Some aircrafts don't need vortex generators because their wing designs may be sufficient for their intended purposes, as well as vehicles. And vehicles are the vortex generators are highly needed in vehicles that are of high speed, like Formula One vehicles, sports cars, those ones in high speed. You need the vehicle to stay to the ground, and that is why vortex generators are important for those vehicles, not the general day-to-day vehicles. So feel free to ask me any questions in the comments. These were the links, or rather the references that I used in the discussion of and research of this topic. Thank you for your attention.